string where we're using money as a model to solve for these fractions. And I hope you enjoyed this series, these 10 strings. If you haven't reviewed them, go back, check them out. The goal from the very beginning was to give us an intuitive way to solve these fractions. Maybe not the most efficient, but it certainly keeps us in check to think about what's actually happening here. Sometimes it's a much better approach, and I think in general it is, than just memorizing algorithms. Thinking about what these might mean. So I hope we have some fun here in this one. I hope you find some cool patterns. I kind of rush through these when I'm talking through them in a video. So maybe you can find some other great patterns, because every string is designed, right? Each of these equations forms a string. It's designed so that there's some interesting pattern between each of the steps to help us understand what's going on. So I hope you see something neat, and if you do, please let me know. Okay, so first we have 2 and 7/100ths. Seems unfriendly, but really 1/100th is just a penny. So this is like saying $2.07 minus $1.07. Well, if 1/100th equals a cent, what does 1/50th equal? Well, I'm going to say 2 cents, because we're taking a dollar, instead of splitting it into 100 groups of pennies, of individual pennies, we're splitting it into 50 groups, and each group will have 2 pennies. 1/50th of a dollar is 2 cents. And that makes sense also because if you take 100, multiply it by 2, you get 50. Divided by 2, you get 50. So the denominator is here half the size as it was before. So altogether, this fraction should be twice as big. Right? We're not changing the numerator. We're just reducing the amount of groups that we're splitting it into by half. So altogether, we're doubling, just as we're doubling 1 cent to 2 cents. Right? So there's a doubling happening there. So if we have 7/50ths, I'm going to say that's 14 cents, right? Because each 1/50th is 2 cents. If we have 7 of them, altogether we have 7 times 2, or 14 cents. So what do we do here? Well, $2.07 minus $1.14. Well, I'm going to say, what's 207 minus a dollar? It's $1.07. And we have to take another 14 cents away. Well, if we're at $1.07 minus 7 cents, that's $1, and another 7 cents, because we have to subtract 14, gives us 93 cents, or 93 out of 100. And, there are many ways to check that, but that's the way I think about it. So now we have 2 and 18/200ths, and 1 minus 1 and 9/100th. So $2, and how many pennies is this? Well, if 1/100th is a cent, what does it mean to have 1/200th, right? So here now, we're doing something different. We're doubling the size of the denominator. So this is going to be an even smaller fraction. So I'm going to say it's half of a cent. So I'm going to write that as 0.00, right? There are 2 zeros now. We have a half of a penny, which is 0.005, right? 2 100ths make 1/100th. In other words, this is a half a penny, so 2 of these have to make a penny. So now we have 18 of them. I'm going to think of that as 18 half pennies. These are half pennies, equals how many whole pennies? Well, 9. Or you have 18 halves, that equals 9 whole pennies. So I'm going to think of it as $2.09 minus, fortunately we have $1.09. And that's just $1, or 1. And that worked out nicely. Moving forward, we have 4 and 12/25ths minus 3 and 2/5. Well, we talked about this in other videos, but $4 and a 25th is like 4 cents. Split $1 in 25ths, you get 4 cents. 12 of those groups give us 48 cents. Minus $3 and what? Well, 2/5, 1/5 is not a nickel. Try and avoid that mistake. That's a major problem or tendency when converting fractions to money. You see a 5 here, you think nickel, but it's not. 2/5 is 40 cents, because 1/5 is a fifth of a dollar or 20 cents. So this has to be 40 cents. So now I'm going to write that as how much? Well, 448 minus $3 is $1. Minus 40 cents is 8 cents, so it's $1.08. Or 1 and 8/100ths. There we go. Got our answers so far. Okay, now we get, I think, a little bit more fun, more fractions, and longer expressions. So fifth minus a tenth minus a 20th. Well, fifth is just 20 cents, minus 10 cents, that's a tenth, minus 5 cents. Much easier to think about. Right? A 20th is a nickel. So 20 cents minus 10 cents is 10 cents, minus 5 cents is 5 cents, so that's a nickel. Just 1/20th. We get a nickel. Okay, next we have a fifth. So again, we have a fifth, and that's 20 cents. Minus a 25th is 4 cents. Minus a 100th is just a penny. So if you have 20 cents and you take 4 away, you have 16 cents. Minus another penny, you have 15 cents. Or 15 out of 100. And last, but not least, we have 1/4, which is a quarter, minus a 25th, which is just 4 cents, minus a 50th, which we established as 2 pennies. So we have 25 cents minus 4 cents, 21 cents, minus 2 cents is 19 cents, or 19 out of 100. Okay, so again, what I wanted to show here is that when you see these fraction problems, try and associate them to coins, or maybe their nearest coin, just to think about what might be happening. So even if you get really unfriendly fractions, you can get a sense of where your answer should be, and you should be able to estimate the answer and predict it within a certain range, and that'll help guide you through much tougher problems. Up next, we have using a clock as a model for fractions. I hope you enjoy it. Thanks.